Welcome back. This is part 2 of the Exam 1 review. Joy Zeigler here. If lines are parallel, that means they have the same slope. For instance, a line that looks like this and another line that looks like that, they have the same slope. They have the same pitch. They're never going to intersect. If a line is perpendicular, that means they form right angles when they intersect, and if they're perpendicular, their slopes are negative, that's 1, reciprocals, that's 2. Now when you think reciprocals, most of you know that means flip it. So take the reciprocal, flip the fraction. But then you have to make it the opposite sign of what it is. So if it's a positive, you have to make it a negative. If it's a negative, you have to make it a positive. Okay, so we need to see what the slopes of these two lines are so that we can compare them and see if they're perpendicular, parallel, or neither. So here are the two lines, and we want to transpose them into slope-intercept form. So let's start with the one on the left. We want our y values on the left, so we basically subtract 3x from both sides, and we get minus 2y equals minus 3x plus 6. And then on the right equation, we want our y's on the left, so we subtract 2x from both sides. And we get 3y equals negative 2x plus 3. Okay, let's look at our left equation again. Now we have to get y by itself, so we divide both sides by what's in front of y, and that means we divide every term by that number, and it's going to be negative 2. So that leaves y equals negative 3 over negative 2 is positive 3 halves, because a negative divided by a negative is a positive. 3 halves x, and then it's plus 6 over 2. Well, plus 6 over negative 2. 6 over 2 is 3, and anything divided by a negative is going to be a negative. Any positive number divided by a negative is going to be a negative. So there's our slope-intercept form for the first line, and the second line we're going to divide everything by positive 3, and we're left with y equals negative 2/3 x plus 3 over 3 is 1. So now we compare slopes. The slopes are, I'm going to do green, 3 halves and negative 2/3. Obviously they're not the same, so we can tell right off the bat these are not parallel lines. Are they negative reciprocals of each other? Well, 3 halves, the reciprocal of 3 halves is 2/3, and then the negative of 2/3 is negative 2/3, and negative 2/3 is the same as this other line. So 3 halves and negative 2/3 are negative reciprocals. That means the lines are perpendicular. We talked in class how slope means rate of change. And when your x-axis is measuring the advancement of time, like in this case from 0 to 4 months, and then your y-axis is measuring some kind of amount, you can tell how that amount increases over time. So in this case, a family may have been saving money, and before they began saving, they had $100 actually in their savings account. So in 2 months, they had $200 in their savings account. So between 0 and 2 months, they had an increase of $100. So the rate of change is $100 over 2 months. Okay, so we're shooting for the answer of $100 over 2 months, which can be reduced to $50 per month. So that is the rate of change. Now the rate of change is increasing. We're adding money each month, and you can tell that because the slope is positive. So this is going to be $50 a month. If it had been a negative slope, the rate of change would have been decreasing. It would be negative 50 a month. Okay, now that I've just talked you through how to find rate of change, but the way to do it using very specific technique is to find the slope of the line. So the slope is going to be the rise over run. Rise over run. So you take any 2 points. We're going to take 100, and let's just take 300 so we can show that it's the same slope. Those are our 2 points, and we count the rise. It goes up 200, goes up 200. So rise is 200, and it goes over 1, 2, 3, 4 months. 200 over 4 is going to equal 50. And what we're talking about is the rise is in dollars and the run is in months. So we have $50 per month. And that's how you find rate of change. Here's another rate of change problem, and you can just look at the graph and see if we're talking about how things change over time. When time starts at 0, let's say in the Garden of Eden, time is starting at 0, we have $300. I don't know where in the Garden of Eden they got $300, but that's not really in the scope of this problem to figure out. So over the course of 4 months, what happens? Well, nothing happens. It doesn't change. It stays that $300. So our amount in savings is $300, but our rate of change, how much we add or subtract to or from that $300, doesn't change. It's 0. We add or subtract 0. So our rate of change is 0. Now, if you go back to our other way of finding rate of change, we look at the slope of this line. It's a horizontal line, so the slope is 0. So either way, you can tell that the rate of change is 0. And it's neither increasing nor decreasing, it's just staying the same. Here's a problem of bicycles. In Lake Travis, they rent for $26, and then you pay an additional $5.25 for every hour that you keep them. Maria was charged $58, so how long did she ride? And you're told to run to the nearest hour. So we're going to do several things, and we're going to write the equation y equals mx plus b, and then we're going to talk about different ordered pairs. We're going to say, what is the ordered pair associated with the equation at x equals 4? And you're given 4 options here. And then finally, we're going to answer the question. If Maria was charged $58, how long did she ride? So I'm going to move this up and over to the side and start with writing the equation in y equals mx plus b. Now we talked about fixed costs and changing costs, variable costs. Y is the total cost. X is the number of hours. M is the variable cost. And the variable cost in this case is $5.25 because you multiply that by the number of hours and it changes depending on how many hours there are. So we don't know how many hours. We're going to put X there. But we do know that what doesn't change is that there will always be a charge of $26. So that's one. That's our y, our slope-intercept equation. So 2, what about if x is 4 hours? So what if x equals 4? Well, x is the number of hours. So we can tell you that right off the bat. If x is 4, we have y equals 5.25 times 4 plus 26. So you can multiply 5.25 times 4 in your head, because if you have $5.25, that times 2 is $10.50, then another $5.25 is $15.75, and another one is $21. So $5.25 times 4 is $21. Or you could just go over here and say $5.25 times 4. 4 times 5 is 20. 4 to 2 is 8, plus 2 is 10. 4 times 5 is 20, plus 1 is 21. Okay, so y is going to be 21 plus 26, which is 47. So when x is 4, y is 47. What does that mean? That means that in 4 hours, you're going to spend 47 to rent this bike. Okay, and as an ordered pair, what is it? It's an x, comma, y. Well, x is 4 and y is 47. So this is an ordered pair, 447, representing 4 hours and a $47 total cost. So if we look at our options, A says the ordered pair is 4.5. Well, I don't know where 5 came from. B says the ordered pair is 447, and that is correct. And it means the charge for riding 4 hours is $47, and that's what we said. C, it has an ordered pair with that 5 again. And D, it has the ordered pair reversed. It puts y first, and that's not correct. So, and I don't know where that 74 came from. I have to fix that. But anyway, so B is the correct answer, and so that's number 2. Number 3, what if, let's forget all of this stuff. This was part B. And we'll go back to our original equation. This time we know that the total charge is $58, so we know y. Y is $58, but we don't know how long you get the bike for if you have $58. So we leave x alone and we solve for it, which means we get x by itself. So let's go ahead and get x all by itself on the right side of the equation by subtracting 26. And we get 58 minus 26 is 32 equals 5.25x. Okay? But we want x by itself, so we're going to divide both sides by 5.25. And remember, you don't get to use a calculator on this exam. So let's go off to the side and find out what 32 divided by 5.25 is. Okay, so a quick review. When you're dividing by a decimal, if your divisor, and this is your divisor, if your divisor has a decimal in it, you have to get rid of the decimal. So you move it 2 places to the right, which means you take this implied decimal here and move it 2 places to the right as well. So when we move it 2 places to the right, then we're moving it 1, 2 here also. So what we really have is, and I'm going to rewrite it in green, 525 as our divisor going into 3200. So the way you do this is you say, how many times does 525 go in to 3200? Well, that's a hard question to answer. Let's just look at the first digits of those numbers. How many times does 5 go into, well, not 3. 5 doesn't go into 3. How many times does 5 go into 32? Well, it goes in 6 times. So let's try the number 6. But we're really asking how many times 525 goes into 3200. So we're going to write the 6 over the last digit in that number. So what is 6 times 525? Okay, down here we're going to quickly write that out. 525 times 6. 6 times 5 is 30. 6 times 2 is 12. Plus 3 is 15. 6 times 5 is 30. 31. So we get 3150. So let's see, I'll use red. 31.50, and that gives us 50 left over. Now it says round to the nearest hour. And right now we have 6 hours done, but we need to know what the next digit is going to be so we know how to round. So there's going to be a decimal point here and a decimal point here. And then we bring down this 0, and we see that 525 doesn't go into 500, so we put a 0 there. Since we're going to round to the nearest 6, all we need is that 0 to tell us we're not going to round up. We're just going to leave the 6 as 6. So the answer is that x equals 6 hours. So that should make you glad you're going to be using your calculator again in the future. But basically all we did was we divided both sides by 5.25 and rounded, and we get that x equals 6 hours. So to refresh what we're doing here, the question was, if Maria's charge was $58, how long did she ride? And the answer is 6 hours.